So now onto our modules. We are matrices, a total of 6 residents from 2 towns will be competing at the international games. Matrix A shown below contains the number of males and the number of females competing from the towns of Gillen and Haldor. Love it. How many of these athletes are residents of Haldor? All right, so male and female Haldor, I reckon it would be just 2 residents. You're looking at that one and that one because they're from Haldor. Each of the 6 athletes will compete in one event: table tennis, running, or basketball. Matrices T and R shown below contain the number of male and female athletes from each town who will compete in the table tennis and running respectively. All right, Matrix B contains the number of male and female athletes from each town who will compete in basketball. Complete Matrix B below. All right, so let's see what we've got here. So we know that we have, all of these values have to add, don't they? Because basically the athletes have all got to add up. Yeah, so in total, if we look at the total 2, 4, 5, there are 6 athletes in total. So we now have to make sure that we sort of keep them the same. I don't know I'm explaining this particularly well. What I notice here is I've got 1 male from Haldor, and there is my 1 male from Haldor. I've got to have 1 female from Haldor, but at this moment in time, they're not there. They're not there. So that must be the 1 female from Haldor must be approaching there. So that's my Haldor gone. I've got 2 males from G. I've forgotten what that's called. Doesn't really matter. Nope. I've got 1 male there, so there must be 1 male there. And I've got 2 females from G there. And there they're already doing it. So that's got to be a 0. And that has to be a 0 as well. So we get 1, 0, 0, 1. Correct answer. Right, so this is just interpreting the information. Matrix C contains the cost of 1 uniform in dollars for each of the 3 events: table tennis, running, and a basketball. For which event will the total cost of uniforms for the athletes be $1,030? Right. So as it turns out, we have 2 people doing tennis, 2 people doing running, and 2 people doing basketball. So if we are looking for 1030, we're trying to work out which of those is going to multiply together to give me 1030. And it would appear that if I do 515 times 2, I in fact get 1030 for which event. And so that would give us table tennis. Write a matrix calculation that includes matrix C to show the total cost of uniforms for the event named in part CI is contained in the matrix answer of 1030. Okay, so we have to include that, which is going to be 515, 550, and 580. And we're going to multiply that by. Now, because we've got table tennis, running, and basketball, we have to keep the order that way. So how many people are doing table tennis? Did we say 2 are doing table tennis? Right, so the total cost units for the event name. So 2 table tennis. We're only interested in table tennis, so when we multiply that together, we do in fact get 1030, and that was what they were looking for. Okay, so part D, matrix V and matrix Q are 2 new matrices where V equals Q times C, and matrix Q is a 4x3 matrix, and we got all the other elements here. So when we multiply this by matrix C, all right, so Q is equal to, let's try that one again. So when we do V equals Q times C, we are going to end up with, we know that Q is a 4x3, C is a 3x1, multiply those together and you are going to end up with a 4x1. Remember, the n values here tell me the dimensions of my final result. Yeah, so Q times C. So we know we've got Q times C, I'm just going to write that here, is going to be equal to a 4 rows by 1 column. Yeah, 4 by 1, and each of these values stands for something. So V11 is females from Gillen, so that's females from Gillen, female from Haldor, male from Gillen, and male from Haldor. So that must mean that each of these columns here stand for the same thing, because when I multiply a row by a column, it's going to give me each of the individual things. So FG, so the first column here, the first row here must stand from the female athletes from Gillen who are doing each of the sports. So females from Haldor, male from Gillen, and male from Haldor. So how many? And we also have to make sure that we've got tennis running, or table tennis, running, and basketball. So how many females were doing table tennis? From Gillen, 1. 1 female was doing running, and that's it. So 1 and 1. So that's going to be 1 female was tennis, 1 female running, 0 from basketball. All right, males from Haldor. Males from Haldor. See, let me see, what did we have? Males from Haldor, 1 was table tennis and 1 was basketball. So 1 was table tennis. Hold on a moment. I misread the question. Yep. So that should be 1 there and a 0 there because there were no males running. Okay, so 1, 2, 3, 4, 5, 6, the numbers all add up. If you want to know what I've just done there, I've just put in, just added those ones together. 3 television channels, C1, C2 and C3 will broadcast the international games in Gillen. Gillen's 2,000 residents, that's going to come in handy, I'm fairly sure, are expected to change television channels from hour to hour as shown in the transition matrix below. The option for residents not to watch television, no TV at that time, is also indicated in the transition matrix. I feel like I've done this question before. The state matrix G0 below lists the number of Gillen residents who are expected to watch the games on each of the channels at the start of a particular day. I have a feeling I remember this as being important. Also shown is the number of Gillen residents who are not expected to watch TV at that time. So there we go, that's that value there, that's that 1400 there. Okay, so this is at 9 a.m. Complete a calculation below to show that 835 Gillen residents are not expected to watch TV at 10 a.m. that day. Okay, so what we would end up doing is we would look at multiplying 100, 400, 100 and 1400 by this. Yes, so Gillen residents. So we'd be looking at this row here, which is my no TV row. All right, so next hour, this hour, yes, so just to break it down one more time, in this hour, the people who go from C1 to no TV is that, from C2 to no TV is that, from C3 to no TV is that, and from no TV to no TV is that. So what we'd be doing is multiplying that row by the column of the values we've been given. So moving that up, that would be 0.15, 0.25, 0.2, and 0.5. When you bang that into your calculator, you get 835. Determine the number of residents expected to watch the game on C3 at 11 a.m. that day. Determine the number of residents expected to watch the games on C3 at 11 a.m. that day. Okay, so first things first, we've got to put in our information to our calculator. So I've now stored my matrix B in there. All right, that's my transition matrix. So now I'm going to do, what am I going to put into my, I'm going to put, there we go. So I'm going to put that into my memory. That's my start answer. And what I'm going to do is I'm going to keep time, I'm going to do B times my previous answer. I have to make sure I get my transition matrix run the right way. So there we go. So having multiplied my transition matrix by the previous, that's what would happen at 10 a.m. So you can see there the 835. Do it again, there would be my 11 a.m. So determine the number of residents expected to watch the games on C3. That would be the third one down, which would be 356. All right, so 356 residents by using your CAS. Okay, basketball finals will be televised on C3 from 12 noon until 4 p.m. Okay. It is expected that 600 Gillen residents will be watching C3 at any time from 12 noon until 4 p.m. It's expected that 600 Gillen residents will be watching C3. Okay. The remaining 1,400 Gillen residents will not be watching C3. Okay, represented by not C3. The transition matrix P below shows how 2,000 Gillen residents are expected to change their viewing habits each hour between watching C3 and not watching C3. Okay. From 12 noon until 4 p.m. Write down the values of V, X, and... Okay, so for a transition matrix, that there is going to be the easiest one to try and find. Okay, so, because we know that for a transition matrix, the rows have to, or the columns have to add to 1. So V there is going to be 0.65. So we now know, because that is 65% of the people who were watching it previously will stay watching it, all right? So they will stay watching it. So that means 65% of, how many people? 600. So if we work out 65% of 600, so 0.65 times 600 gives me 390. So that means that 390 people will stay. So that means that we would have to have 600 minus 390, 210 people come from somewhere else. All right, so where are they going to come from? Well, they're going to come from the people who were not watching it the previous hour. So that's 1,400 people. So we're going to have 210 out of 1,400. 10 divided by 1,400 times, so that is going to give me a value of 0.15. All right, so that's my transition matrix of 0.15. So these people will have been going from not C3 to C3. So W there would have to be 0.15, and then because that's 0.15, X must be 0.85. After 5 p.m, tourists will start to arrive in Gillen and they will stay overnight. As a result, the number of people in Gillen will increase. The television viewing habits of the tourists will also be monitored. Assume that 50 tourists arrive every hour. Okay, that's going to be 50 tourists. It is expected that 80% of arriving tourists will watch only C2 during the hour they arrive. The remaining 20% will not watch television during the hour they arrive. Whew. Let WM be the state matrix that shows the number of people in each category M hours after 5 p.m. on this day. The recurrence relation that models the change in the television viewing habits of this increasing number of people, blah, 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 5 p.m. on the day shown. Where? Whew. That was a lot of work. Right, so there's my T, next hour, and there's my W0. Write down matrix V. Okay, so matrix V is going to be equal to, bearing in mind the information told us that 50 people in total were going to arrive, so we know that the column of this has to add to be 50. It's expected that 80% will only watch C2, so we want 80% of those 50, which gives me 40 will watch C2, so no one on C1, 40 on C2, none on C3, and because it must add to make 50, there we go, that's matrix V. Whew. Okay, so we've already put in B into this here. How many people are expected? So what I'm going to do now is I'm going to say, right, well, let's start off with my original value. I'm going to set up a recurrence relationship. So there we go. So a 4 by 1, and we're going to put in W zeros, 400, 600, 300, and 700. Ka-ching. Now, we want to take all of our previous answers, W0 in this situation, and we're going to do B times, oops, he says, A and S. And we're going to add on our matrix V, what is it? V, in fact, yep, 4 by 1. And we know that that was 0, 40, oops, 0, and 10. So that there represents 5 p.m., 6 p.m., and there is 7 p.m. So in that situation, how many people in Gillen are expected to watch C2 at 7 p.m. on this day? It would be 666 people. It's really hard to know for the 2 marks what working out I was going to show there. How many people in Gillen are expected to watch C2 at that? So I would assume in that situation they would either be wanting you to put your intermediary values. So you would put basically, you know, W0 equals, you put W1 equals, and then W2 equals, and therefore put the 666. Remember, for 2 marks, you've got to show some form of working out. Okay, moving on to networks now. A zoo has an entrance, a cafe, and 9 animal exhibits. Oh, geez. Entrance, a cafe, and 9 animal exhibits. Yep, the edges on the graph represent the path between the entrance, the cafe, and the animal exhibits. The number on each edge represents the length in meters along that path. Visitors in the zoo can only use these paths to travel around the zoo. Awesome. What is the shortest distance in meters between the entrance and the seal exhibit? Well, there's the entrance, and there is the seal exhibit. So hopefully, trying to find the shortest distance between the entrance and the seal exhibit would be 25 plus the 20, which would be 45 meters. Job done. Freddie is a visitor to the zoo. He wishes to visit the cafe and each animal exhibit just once, starting and ending at the entrance. What is the mathematical term used to describe this? So if you are going to visit it each and only once, that is a Hamiltonian. All right, so it's Hamiltonian. And what did he say? He's starting and ending at the entrance, so it's got to be a cycle. All right. Oh, no, circuit. Sorry. It's got to be a Hamiltonian. No, cycle. All right. So a Hamiltonian cycle. Draw one possible route that Freddie may take on the graph below. Where's he going? So one possible route on the graph below is starting. He wishes to visit the cafe in each animal exhibit just once, starting and ending at the entrance. So doof, 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 and doof. There we go. So that is one possible route that he could take. Yep, and that worked well for the answers. How many marks was that? 1 mark, good. Reptile exhibit R will be added to the zoo. A new path of length 20 meters will be built between the reptile exhibit R and the giraffe. So reptiles, so there's my giraffe. Where's my reptiles? Oh, it's not on there yet. A second new path of length 35 meters, sorry, will be built between the reptile and the cafe. Okay, complete the graph below with the new reptile exhibit and the 2 new paths added. Label the new vertex R and write down the distance on the edges. Reptile and giraffe, and reptile and cafe. All right, so let's just do that there and call it R. And we'll join it together. And giraffe to the reptile was 20, and reptile to the cafe was 35. All right, the new path reduces the minimum distance that visitors have to walk between the giraffe exhibit and the cafe. By how many meters will these new paths reduce the minimum distance between the giraffe exhibit and the cafe? Okay, so if we look at the now path length as 55 meters, so the new path length is 55 meters. Let's look at other ways of being able to get from the giraffes to the cafe. So 15, 35, 40, and 50. So if we add those together, gives me 50, 140 meters. So that's one way. Let's see if there's a different way. What about going 55 to 40 to 50? 55, 105, that's 145 meters. So that's no shorter. What about going the long way around? Let's do 45 to get to there, and 25 gives me 45, 55, 65, 70, 80, 90, 130, 140, 155, I think that way is. Let's just check that, it doesn't make sense. 45, 40, 50, 70, 80, 90, 130, 155. Is there another way? 40 and the 25 gives me, I've just done that, 40, 50, 60, 70, 100, 140. There's another way there of 140. Can we make it any shorter? I don't think we actually can. All right, so in which case, I think our shortest distance there is going to be the 140. And so the old way was 140. So the distance, the minimum, or the new path, the reduction is the word I'm looking for, is 140 minus 55, which gives me 85 meters. Ka-ching. The construction of the new reptile exhibit is a project involving 9 activities A to I. The directed network below shows these activities and their completion time in weeks. Which activities have more than one immediate predecessor? Which of these activities have more than one immediate predecessor? Okay, so if we look at this, that's got 2. Immediate predecessor, 2 immediate predecessor. That has an immediate predecessor because it's got 2 coming off of there, and G has an immediate predecessor. So I think it's D, G, and I. Yep. All right, so those are the ones there. D, G, and I are the ones that have more than one immediate predecessor, because I can't start G until E and F are finished. I can't start I until G and H are finished, and I can't start D until C and B are finished. Write down the critical path for this project. All right, again, lots of ways of doing this. Let's just do the crashing. All right, I'll be back in I'll just do this because it takes some time. Okay, so there we go, filling that in. There is my forwards and backwards scanning. Write down the critical path. Remember, the critical path is anywhere where the values are the same. So let's just say that that would be A, C, D, F, G, and I. Yep. Okay. What is the latest start time in weeks for activity B? 2 weeks. All right, and again, that's just read off that value there. Okay. Oh, end of question. No crashing for that one. Whew, thank you. The zoo's management request quotes for parts. Oh, here we go. Of the new building works. 4 businesses each submit quotes for different tasks. Each business will be offered only one task. The quoted cost in 100,000 of providing the work is shown. The quoted cost in $100,000 is shown in table 1 below. Okay. The zoo's management wants to complete the new building works at a minimum cost. Of course they do. The Hungarian algorithm is used to determine the allocation of tasks to businesses. The first step of the algorithm involves row reduction, that is subtracting the smallest element in each row of table 1 from each of the elements in that row. The result of the first step is shown in table 2. Thanks for that. The second step of the Hungarian algorithm involves column reduction, that is subtracting the smallest element in each column of table 2 from each of the element in that column. It's going to take me longer than the exam to read the question. The result of the second step of the Hungarian algorithm are shown in table 3 below. The values of task 1 are given as A, B, C, and D. Task 1. Okay. The second step of the algorithm is column reduction, that's subtracting the smallest element in each column of table 2 from each element of column 1. The result of the second step of the Hungarian algorithm are shown as the value of task 1 are given as A, B, C, and D. Write down the values of A, B, C, and D. Okay, so we've got to subtract the smallest element in each column. All right, so I'm just going to check with one of the columns to make sure that I've actually got it right. So in this situation here, the smallest value is in fact 2. So I should have got 5, 5, 0, and 1. Let's just check that we actually got that 5, 5, 0, and 1 so I remember how to use the algorithm or read one or the other. Okay, so now let's do this one here. The smallest value in there is 5, so it's going to be 2, 1, 1, and 0. 2, 1, 1, and 0. So 2, 1, 1, and 0. The next step of the Hungarian algorithm involves covering all the 0 elements with horizontal or vertical lines. The minimum number of lines required to cover the zeros is 3. Draw these lines on the table above. So I'm going to replace that with 2, 1, 1, and 0. So 3 lines is the minimum in which I can do it. 1, 2, and 3. And again, that is the correct answer. An allocation for minimum cost is not yet possible. When all the steps of the Hungarian algorithm are complete, a bipartite graph can show the allocation for minimum cost. Complete the bipartite graph below to show this allocation for minimum cost. Okay, so the third, basically this is just telling me you've got to continue with the Hungarian algorithm. And how are we going to do that? Right, so reading this now, having done this, because you can only continue when there are 4 lines covering the zeros. Add the smallest uncovered value to any value that is covered by 2 lines. So the smallest uncovered value in this situation would be 0. That's 0, that's a 1. I've just put a square around the 1. All right. Add the smallest uncovered value to any value that's covered by 2 lines. Subtract, so add that to anything that is covered by 2 lines. All right, so that's now going to become 3, and that's now going to become 2. Okay, we can do that. Subtract the smallest uncovered value from all of the uncovered values. All right, so that now becomes 1, that becomes 0, that becomes 4, that becomes 4, that becomes 1, and that becomes 2. Okay, now let's repeat the whole lines business. Can I do this in any other way? Well, as far as I can see here, there is 1, 2, 3. There is no other way. If I draw an additional line through here, that is my 4th line, 4 tasks to be allocated. All right, complete the bipartite graph to show this allocation for a minimum cost. So let me see. Business 2 can do task 1. And business 4 can do task 1. So anywhere there's a 0, if you remember, business 3 is task 2. Business 1 and 2 can do task 3. Business 1 can do task 3, and business 2 can do task 3. and businesses 3 and 4 can do task 4. Task 4, businesses 3 and 4. Business 3 can do task 4, business 4 can do task 4. Okay, so then what we need to do is choose the ones that we actually know can do. So business 3 can only do task 2, which means business 4 can only do task 4. Business 3, we've got business 4, we've got business 2, can in which case do... So let me see. I'm going to rub some of this out because this is going to confuse the life out of me now. That one has gone. That one has also gone. Okay, so we got chushk, and we got chushk, and we got chushk, and we got chushk. All right, so task 2 and task 4 already done. So business 1 can only do task 3, which leaves business 2 to do task 1. So business 4, task 4, and there we go. That's actually what they wanted as the answer. I'm going to be honest there, that was a bit confusing. I would have just done the bipartite graph with all of the thing, but it wanted the final allocations. Business 4 has changed its quote for the construction of the pathway. The new cost is $1 million. $1 million. The overall minimum cost of the building work is now reduced by reallocating the tasks. How much is this reduction? Guys, I'm going to cop out on this one. Business 4 has changed its quote for the construction of the pathway. The new cost is $1 million. The overall minimum cost of the building works is now reduced by reallocating the task. How much is this reduction? I'm just going to write the answer from the VCAA exam, which is $200,000. It's just because recording this has taken hours today, and I've still got 2 more modules to do. So please bear with me. If I can, I'll update the answer individually on mathsguru.com, where the answers are individual rather than the whole video. Because once I upload these to YouTube, they don't let me replace the videos, which I can sort of understand. So I'm just going to go with 200,000 at the moment and think about that a little bit more and maybe update it on Mathsguru. All right, geometry and measurement. An engineering conference is being held in Rome. Rome is located at latitude 42 degrees north and longitude 12 degrees east. 4 presenters from different cities will travel to Rome to attend the conference. Presenters and the coordinates, latitude and longitude of the city each presenter live in are shown below. Which presenter lives closest to Rome? Okay, so here I always draw a circle when I do these ones. It's located at latitude 42 degrees north. All right, 42 degrees north. So let's say that's 42 degrees north, and longitude 12 degrees east. All right, Yvette, 3 degrees south. So where's Yvette going to be? Roughly speaking, 3 degrees south, 12 degrees east. So that's Yvette. We've got Anthony, 17 degrees south. Rihanna is going to be 54 degrees north. So Rihanna is going to be 10 degrees from. Yvette was going to be quite some. And Shana was going to be 65 degrees north. So I would say Rani. Okay, Rome has a latitude of 42 degrees north. The diagram below shows the small circle of Earth with latitude 42 degrees north. Okay, so the small circle is actually this one here, yeah? Okay, calculate the radius of the small circle of Earth with a latitude of 42 degrees. Right, now how does this help us? Well, first things first, that angle there is 42 degrees, but the trick of it is that that length there, from the center to the edge of the Earth, is also 6,400 kilometers. You will not know how long I've sat here, trying to learn to draw triangles. So if I look to draw that again, that's 6,400, that's 42 degrees, and that's the value of r. So we can use that because I've got the hypotenuse, I've got the adjacent, I can use cosine. So we know the cosine of the angle of 42 degrees is equal to the adjacent, which is r, divided by 6,400. So r becomes equal to, let's fire up my Kaz, he says, 6,400, 6,400, yep, times trig, the cosine of 42 degrees. And always remember that you have your calculator on degrees mode. If you have it in radians, it's going to cause some very, very silly answers. So 4,756 kilometers. The key speaker, Michael, will travel from Auckland to Rome to attend a conference. Well, just because I happen to know that, here is Auckland and here is Rome. Okay, so Michael left Auckland at 9:40 a.m. on Monday. So I'm going to write 9:40 on Monday. The journey to Rome took 30 hours. The time difference between Auckland and Rome is 10 hours. On what day and at what time did Michael arrive in Rome? Okay, so he's actually going backwards in time. All right, so the journey to Rome took 30 hours. So if we were to add on 30 hours to his standard time, then he would be adding on a day and 6 hours. So 9, 10, 11, 12, 1, 2, 3. So he would be there at 15:40 on Tuesday in Auckland time. The time difference between Auckland and Rome is 10 hours. All right, so that's 10 hours backwards. On what day and at what time did Michael arrive in Rome? 10 hours off of 3 p.m. is 3 a.m. Sorry, try that one again. Take 10 hours off of 3:40 is going to give me 5:40 on Tuesday morning. So 5:40 a.m. on Tuesday morning. Now again, when I do these, I always look at the time that I started. I will work out by adding on the 30 hours to see what time it would have been in Auckland, and then look at any time difference to give me the time where I'm going to be. Always making sure that I know that Rome is backwards. So we go backwards in time. Michael would present a building design at a conference. The horizontal cross-section of the building is in the shape of a regular hexagon. Each side of the hexagon is 12 meters long. Triangle ABC shown shaded. Show with calculations of the area of triangle ABC rounded to one decimal place is 62.4 meters squared. Okay, so I'm going to use the area of a half AB sine C. That's the form I'm going to use because I know that this length here is 12, I know that length there is 12, and I can work out that angle there because it's a regular hexagon. I can basically work out that that angle there is 360 degrees, he says degrees, divided by 1, 2, 3, 4, 5, 6. So that angle there is going to be 60 degrees. So using that, I'm going to have the area, and because it says show with calculations, half times 12 times 12 times the sine of 60 degrees, which gives me, he says, going to his calculator, a 0.5 times 12 times 12 times the sine of 60 degrees gives me 62.4 meters, or meters squared. Calculate the area of the hexagon, round your answer to the nearest square meter. Well, if I know the area of one square or one triangle, then all I need to do is multiply it by 6. So therefore, I'll do 62.4 times 6. Now, I'm not going to use 62.4. I'm going to actually use my calculator answer. So I'm going to take that answer and times it by 6. Gives me 374 to the nearest square meter. 374 square meters. A hemispherical dome will sit on the roof of the building. Now remember, a hemisphere is basically half a football. Right, this is a plan view looking down. The dome has a diameter of 20 meters. The view of the building from above, thank you very much, it actually showed me it was from above, is in the diagram below. The area of the roof that surrounds the dome is shaded in the diagram above. Calculate this shaded area. Well, it just so happens you've already worked out the area of that hexagon there as 374 square meters, right? So you've already got that. So what we now need to do is work out the area of this circle, all right, and it is a circle, and then take them away. Now, because they've given me a diameter there, it's a trick. So the area is equal to pi times the radius squared, which is going to be pi times the radius is 10, which is 10 squared. So if I do now 10 times 10, I'm going to times that by pi, gives me 314.159 meters. So 314.159 0.159 square meters. Right, so that's the area of the circle. We're now going to take that away from 374. So I'm going to subtract that from that one there. Gives me 60 square meters. All right, so again, I'll just write down, I don't have to write down the calculator. 374 minus 314.159 gives me 60 square meters. All right, correct to the nearest square meter. The top of the hemispherical dome will be made of glass, as shown shaded in the diagram below. The glass section of a base diameter of D and a height of h meters. The area of the base of the glass section is 1/4 the area of the base of the glass section. So that there is 1/4 of the area of the base of the dome. So let's call that area, and that's 1/4 of its area. Show a calculation of the base diameter of the glass section D is 10 meters. Okay, now the reason they're doing this is it's a ratio question. And so what we know is if the area is equal to 1/4, we know that the heights or the diameters or any lengths are in a ratio. So what we would normally do is we would find the ratio of we'd normally find the ratio between the diameters. So I think that's got to be D on 20, yes, because it's going to be a smaller value. D on 20 is equal to 1/4. So if we now square that out, we get D squared on 400 equals 1/4. Multiply that all up, gives me 4D squared is equal to 400. Divide both sides by 4 gives me 100, and therefore my diameter does come out to be 10 meters. All right, so again, in that situation, it's all about similar areas or similarity. All right, so we can find the scale factor of enlargement or reduction because we're going here. We know that we've got the enlargement is D on 20, similar figures. And we know that to do areas, we have to square that scale factor. And we know, because they've told us what the actual fraction is equal to 1/4, and then you can just solve it. I don't know that they'd expect you to do all of this for 1 mark. I think you probably would just have to put this here, and then you would use your CAS to solve it. Okay, so in part 2, calculate the height h in meters of the glass section of the dome. Round your answer to 2 decimal places. And I will be honest with you, this one gave me a little bit of head scratching for a moment. But, all right, so what I want you to imagine is that the top part of the dome is this section here with the dotted line. We already knew that the diameter of this was 20. That was given in the question. We knew, because we had just found it, that the diameter of that was 10, which meant that when we looked at situations here, that means from the radius or from the middle to the edge, i.e. a radius, was 10. And so what we knew was that, doing it in a slightly different color, let's change color, we knew that this was 10, and I knew that this was 10. All right, so that was a horrible line there. So let's just do that one again. That was 10. How does that help me? Well, we also know that this here was 5. And if I drew one construction line, which was from here to here, that was also 10, because from the center to the edge is always a radius. Now, how does that help me? Let's get rid of all these colored lines for the moment. Can I get rid of those two? I can. All right, so what we now know is that this height here is 10. And using Pythag, I have a right angle triangle, which means I can find this height here. I can find the bit of the dome that isn't glass, that height there, which when I take that away from 10, you see where I'm going with this? I'll be able to find my height here. So let's call that X for the moment. We would know, doing a calculation over here, that 5 squared plus X squared equals 10 squared. Yeah, so just using Pythagoras theorem, which gives me that X squared is 10 squared minus 5 squared, or X is equal to the square root of 10 squared minus 5 squared. That's X. So how do we find the value of H? Well, if we do H is equal to 10 minus the value of X, which is 10 squared minus 5 squared, that should give us the right answer. So let's put this into my calculator. 10 minus, please, the square root of, we can do those in my head, 100 minus 25 gives me the value of 1.34. So we know that h is 1.34 and meters. Remember, it says to 2 decimal places. Some of the presenters organised a helicopter tour of nearby landmarks. The tour starts in Rome and travels directly to Genzano di Rombo. Ah, not bad. Or Roma, I should have said, as shown in the diagram below. Genzano di Roma is 37 kilometres from Rome on a bearing of 153 degrees. So I'm going to zoom in for a moment. We now know that that bearing there is 153 degrees, and it told me that it was a distance of 37 kilometers. How is that going to help me? How far south of Rome is Genzano di Roma? Okay, so this is one of those standard type of questions. I'm going to split this into a right angle triangle, because then I can use trigonometry. How do I use trig? Well, I can find that angle there by doing 180 minus 153 gives me this angle in here in 27 degrees. I've got an angle, one side, and I'm going to try and find another side. Let's call it x again. I love x as a letter. And I'm fairly sure we have everything we need to help us find that distance. So what have we got? We've got an adjacent and a hypotenuse, so it's cos. So cos of my angle is equal to my adjacent length divided by my hypotenuse. So x becomes equal to 37 times the cos of 27. And again, 37 times the cosine of 27 gives me 30, what does it want? To the nearest kilometre, 33 kilometres. And again, always make sure you check those units. Okay, so the next part of the question says, from Genzano di Roma, I'm going to keep saying that, the helicopter then followed a route to Tivoli, Calcutta, and then to Rome, as shown in the diagram below. Okie dokie, thank you very much. Tivoli is 25 kilometres. Now, I'm looking at this already and thinking, sine rule, cosine rule. We haven't had those yet. Tivoli is 25 kilometres from Genzano di Roma. So that there is 25 on a bearing of 16 degrees. So I now know that that there is 16 degrees. Calcutta is 42 from Tivoli, 42. And I'm already suggesting now, because I've got two sides, that this is going to be hopefully a cosine question. All right, on a bearing of, Calcutta is 42 from Tivoli on a bearing of 309 degrees. Now, what that means is that this whole bearing here is 309 degrees. Calculate the distance between Genzano di Roma and Calcutta. So what they're trying to do is find this distance here. He says, hoping there we go, they'll turn that into a straight line. So that's that distance there, right? 100% cosine rule now. To be able to find to use the cosine rule, I have to find this angle in here. How am I going to do that? Well, I know that from Tivoli to Calcutta, that is 309 degrees. So if I do 360 minus 309, I get 51 degrees. Now, how's that helping me? That tells me that this angle in here is 51 degrees. And you're going to say, well, that's not helped me at all. Actually, yes, it has. Because I also know that when I have co-interior angles, the angle in these two dots here must add up to 180 degrees. I've already got 16 degrees here. And part of this angle outside is 51. So if I now do 180 minus 16 minus 51, that is going to give me 113 degrees. That angle in there is 113 degrees. And now I have everything I need to know because I'm going to use the cosine rule. And that tells me that, let's say, c squared is equal to, so I'm going to call this side c, is going to be 42 squared plus 25 squared minus 2 times 42 times 25 times the cosine of the included angle. All right, so having written that down, I'm going to move my diagram off for a moment, just give myself some screen real estate, and hopefully you can actually see over my big fat head. So 42 squared, let's just lean over because this will be quicker, 42 squared plus 25 squared minus 2 times 42 times 25 times the cosine of 113 degrees. Just check that to make sure I get it right. 42, 25, 2, 42, 25, cosine of 113 degrees. That gives me that. Now remember, that's my value of c squared, which is 3209.54. So if I now square root my answer, I get 56.6528. And what's my degree of accuracy? Nearest kilometre. So that should be 57 kilometres. Calcutta is 40.3 kilometres north. I've got to go back to my diagram. Let's zoom out a little bit so I can do this. Calcutta is 40.3 kilometres north and 11.8 kilometres west. Now again, I think this is going to be trying to give me a right angle triangle. That is a horrible right angle triangle, but let's go with it for the moment. So 40.3 kilometres, so I know that's 40.3. And what do we do? 11.8 kilometres, right. Calculate the bearing of Rome from Calcutta. All right, so if we're going from Calcutta, we want this angle here. All right, so we want that. No, we don't. I've gone a little bit too far. Try that one again. We want this angle here. How am I going to find that? Well, if I can find this little angle in here, I can take it away from 180 degrees and that will give me that value there. So 40.3, 11.8. So I've got an opposite and adjacent, it's tan. So I now know that the tan of my angle, let's call it X, is the opposite, which was 11.8, divided by the adjacent, opposite over adjacent, and that will give me the value of X equals. So let's go trig, inverse tan of 11.8 divided by 40.3. It gives me 16.3202 degrees, probably more than that. And now, is that my answer? No, because I therefore have to say, therefore, the bearing is equal to 180 minus 16.3202, and it wants it to the nearest degree. So 180 minus my previous answer, please, to the nearest degree gives me 164 degrees. And here is my graphs and relations section. Rumi has a small clothes shop. He sells men's ties and cravats. All ties are the same price and all cravats are the same price. T represents the selling price of each tie. C, the selling price of each cravat. So we've got tie and cravat. Thank you very much. Each tie and each cravat. Change that to yellow. One customer, Andy, purchases 6 ties, 4 cravats, $230, and there is an equation that basically says that 6 ties and 4 cravats is $230. A second customer, Barry, purchases 4 ties and 8 cravats and pays $260. Write down a linear relationship representing Barry's purchase. So we would have 4T plus 8C would be equal to 260. Ka-ching. The selling price of each cravat in Rumi shop is $20. Right, so that's the selling price of a cravat. So I'm now saying C is equal to 20. What is the selling price of a tie? I can use that previous value to allow me to then work out the tie, because I would know that 4 ties plus 8 times 20 would be equal to 260. 4 ties, 8 20s is 160. Equals 260. 4 ties, take away 160 from both sides, gives me 100. Divide both sides by 4, gives me that the cost of a tie would be $25. All right, customers who visit Rumi shop park their cars in an underground car park. The graph below shows the total charge for parking in dollars. Right, so this is a step graph. Okay, so on Monday, Leon parked in the underground car park for 2 hours and Lucy parked for 1.5 hours. What was the total combined charge? All right, so for 2 hours, they would be paying $5, and for 1.5 hours, which is roughly there, also $5. So the total combined cost would be $10. Customers who park for more than 4 hours are charged $11.50 if they do not stay longer than 5 hours. So who park for more than 4 but less than 5, or don't stay longer than 5, it includes 5. Add this information to the graph above, so it's $11.50. And again, you guys would have to be super accurate, but $11.50 would be here. So I would do an open circle there, I would do a closed circle there, and I would draw a line between the two of them. And ka-ching, that is that mark. Love that mark, that was awesome. A little bit of colouring in. On another day, Pam parks in an underground car park on both Tuesday and Wednesday. Each day she parks for more than 2 hours, but less than 4. So more than 2 hours, but less than 4. So she's somewhere in this section here. Pam was charged less than $20. So that's important, less than $20 in total for the 2 days. Write down 2 possible amounts that Pam could have been charged. Okay, so for the 2 days, she could have basically been both days there. She could have had both days at $8, so that would have been $16. Or she could have had one of the days at $8 and one of the days at $10, which would give me $18. Bearing in mind, because it said less than $20, she can't be in there both for the 2 days. She can't be both $10 a day, because it has to be less than 20. So my two amounts in that situation would be $16 and $18. Question 3, Rumi's web designers, Jeff and George, Judy and Jeff. Where did I get Jeff and George from? Judy and Jeff charge fees that consist of a fixed amount and a charge per hour. The graph of the fee charge for the number of hours worked by Judy is shown below. Judy, just Judy, remember this, just Judy. Complete, or judge Judy, moving on. Complete the following sentence. Judy charges a fixed amount. Well, the fixed amount in this situation or in these graphs are where the intercept is. It has to be 0, so it has to be specifically the intercept. So if I zoom in here, it would appear that that intercept there is at 50. So we can change this value here to 50. That's my fixed charge, and a charge per hour. That's just another way of saying the gradient. And what I do is, if you remember, you try and choose a point that they give you that's nice and on a crossing point. I'm going to choose that one there. I do my rise over my run. So we know my run there is 1 hour. And then we go from 50 all the way up to 140. And so that would be $90. And therefore my gradient would be equal to 90 divided by 1, or 90. So in which case they would charge per hour of $90. Whoop whoop. Judy and Jeff both charge a fee of $320 for 3 hours work. Jeff's charge per hour is $100. Draw the linear relationship. So the reason they're telling you this is, rubbing this out so that we don't get in the way of my graph. The reason we're telling you this is because, first things first, they're telling you a coordinate that for 3 hours work, Jeff and Judy both charge $320. So there we go. So we now know that that is 1 point on my graph. It also says that Jeff's charge per hour is $100. So that means I can now go back an hour, yes, and I'm going to drop $100. So what was that? 320, 220, which is going to be there. So that's basically just a way of giving you another coordinate. We could have actually added on $100 to this one here if I'd wanted to, and that would have given me this point here. So I've now got 3 points. It wants me to basically connect those together. So what I'm going to do is I'm going to draw a dotted line through there. There we go. Now, luckily, if I touch that, it will actually allow me to extend. Now again, you guys will be able to do this ridiculously accurately. But there we go. I think that's a fairly good representation of the line for, who would that be, George? And on to question 4. Rumi also sells jackets for men and women. Let X be the number of jackets for men that Rumi sells in 1 week. Y be the number of jackets for women. So I'm going to write that down then. X is men and Y is women. I always forget the variables. Old age. These constraints are represented by inequalities 1 to 4. Explain what inequality 3 and inequality 4 tells us about the number of jackets that Rumi sells each week. So basically the total of men's and women's jackets, right? Because that's what it's dealing with. X plus Y is the total of men's and women's jackets, is between 40 and 100. Okay, so less than or greater than 40, greater than or equal to 40, less than or equal to 100. All of these words were important, but it had to say that you knew it meant the jackets fell between 40 and 100. Ooh, feasible regions. Here we go. Rumi makes a profit of $30 on the sale of each jacket for men and a profit of $50 on the jacket for women. Determine the maximum profit that Rumi can make on all sales of jackets in 1 week. All right, so first things first, we know that our profit function, all right, objective function, would be 30, now was X men, yep, X men, 30X plus 50Y. I think I'm going slowly mad doing these questions, all right, because I'm talking to myself. 30X plus 50Y. Determine the maximum profit she can make in 1 week. Well, we know that if you have an objective function, we would be looking to turn this into a gradient. All right, so the sliding line principle. So the first things first is I always get the y on its own. So I'm going to try and get the y on its own. That'll give me minus 30x plus p equals 50y. I don't like that at all, so I'm going to write that the other way around. 50y is equal to minus 30x plus p. Divide both sides by 50. Tells me p on 50. This thing here is the important thing. That's the gradient of my objective function. All right. So that's equal to minus 3/5. Now, how do we do that? Now, a great thing again here is I now know that I have a rise of minus 3 and a run of 5. So I'm actually going to put a point here at 30 and a point here at 50. And I'm actually going to make my line a lot thicker. And I'm going to basically connect those two together. Oh, that was a bit thicker than I actually needed, with a line. I'm going to show you why, because this is like the sliding line method or whatever it's called. All right, so for some reason it doesn't want me to do this line again. There it does. Come on, you can do it. Right, so what I'm now going to do is I can move, he says, this line around. And if you remember, we're going to try and slide it so that the maximum is where it's going to hit, and it just so happens it's going to hit at that point there. So here is the point where my maximum profit's going to be, and in which case that would be 20 x's. So x equals 20. Oh, let's actually turn that one off. So we've got x is equal to 20 and y would be equal to 80. And I just put that into my profit function now. So p becomes equal to 30 times 20 plus 80 times 50. Yeah, so 30 times 20 plus 80 times 50. Put that into my calculator. 30 times 20 plus 80 times 50 gives me $4,600. Ka-ching, very excited by that. All right, in a particular week, Ruby sold exactly 30 jackets for men, determine the maximum profit that Ruby could make on all sales of jackets in that week. So 30 jackets for men would give me here, so 30 and 70. So x would be equal to 30 and y would be equal to 70. And again, because I got my profit function, it stays exactly the same as the last question, which was 30x plus 50y. So 30 times 30 plus 50 times 70 should give me, so 30 times 30 plus 50 times 70 gives me $4,400. Ka-ching, and that's the right answer. Later, Rumi finds out the profit he makes on the sale of each jacket for women has changed. Okay, the profit on the sale of the jacket for men remains at $30. The maximum profit he can make in 1 week will now be a different amount. Last week, Rumi was able to make this maximum profit by selling 65 jackets for men and 35 jackets for women. All right, 65 jackets for men and 35 jackets for women. All right, so 65 for men and 35 for women. Now, actually, that puts me there. Now, if that's a maximum profit, it means all the points along that line will also give a maximum profit. Oh, right? That's the whole point of this sliding line objective function. So if I can now find the equation of that line there, yes, then we will be sorted. Now, why? So we already know there because, and again, this is a trick, because it starts at 100 on the x and finishes at 100 on the y, or vice versa, as I just said there, we know that's going to have a gradient of 1. But more importantly here, my gradient is going to be equal to minus 1. So how's that going to give me any advice here? Well, if we have here p is equal to ax plus by, let's assume we have p is equal to ax plus by. All right, we know the profit function is ax plus by, but because we know this has a gradient of -1, that basically means the value of a and b must be the same. Yes, because otherwise you're not going to get the gradient of -1, because when we do a divided by b, if they're not the same, it's not going to give me 1. Well, they've already told me the profit function of the men's jackets is $30, which means that the women's jackets is also going to be $30. So p in that situation is now going to be 30x plus 30y. know my profit function. Can I work out the profit? Yes, of course I can, because they've now given me a value of X and Y, which we used earlier. So I now know that P is going to be 30 times the number of men's jackets, which is 65, plus 30 times the number of women's jackets, which is 35. So 30 times 65 plus 30 times 35 gives me $3,000. And there we go. That's the end of this particular paper. Thank you very much for watching. Hopefully you found it useful. My name's Darren Maths Guru. There are lots more videos over on mathsguru.com and more videos coming in this series. Spread the word. Thank you very much for taking the time to view it. Stay safe.